the reactant is smaller, then we have the K, or the constant rate, the constant of the rate is bigger, like given by the light blue line. Have a look over there. So this is the example. Consider the process in reaction of methyl isonitrile that converted to acetonitril. How do we know that this is a first order reaction? So as we experimentally, this is the data. By plotting the length of the concentration of product to the time of the reaction, if we have the straight line as I discussed earlier, then we are quite convinced that our reaction is first order. So it is quite clear, I think, when we have the data and we plot the data, especially between learned concentration of reactant versus the time, and then we get a straight line with, as I showed you earlier, then certainly we are quite convinced that our reaction have first order. Let's go back to the next slide, talking about half-life. Again, go to the whiteboard here. So we already have that first order reaction. We have ln A is equal to ln I0 minus KT. And we talk about half-life. Half-life is actually the time taken for the reactant to drop to half its original value. Meaning that when A is concentration of reactant A is equal to the initial concentration of the reactant, then then this called the time to get that called half-life. Then how to get to half-life of that first order reaction? Just put it over here. That one can be written like this. Certainly learn A per A0 is equal to minus KT, and put it A over there is equal half A0. This A0 equal to KT of half. So we just cross this, then we get ln a half equal to minus KT a half. And we know exactly that the value of this is equal, the value of ln a half equal to 0.693 equal to minus kt a half. From that one, we get that t a half equal to 0.693 per. Okay. For first order reaction. So all three purpose in learning this chemical kinetics for first part, one for first order reaction about Kt we already carried equal to this first one, and the second one talking about K from the graph, and the third one about T of half already we carried. Now our purpose learning is to get this, all of these for second order. Let's go to second order reaction. Now, again, second order. Very similar. For example, we have A plus B, reactant A react to reactant B, producing a product. And again, in this time, we will have this. First, when A concentration of A, initial concentration of A equal to initial concentration of B, then this one, the reaction rate represented by dA per dt, that one is equal to minus K A squared. But when we have initial concentration 0, not the same as initial concentration of B, then rate reaction is given by dA per dt is equal minus K times A times concentration of B, like this. So quite different. Let's go to the integrate the equation as we already learned for the first reaction. Again, one about the equation Kt equal to, the second is K from the graphic, and 3 is T half or half life. Now we go first one. First one, we would like to get this equation Kt, but only for the simple reaction with initial concentration of A equal to the initial concentration of B. Okay. So, meaning that here dA per dt is equal to minus K A squared. Is it? Isn't it? then we can rearrange it by this equal to, sorry again, this per a square k t. Now we integrate it from a0 to a and from t0 to t. So what we have from over there is that from here what we get, sorry, what is not quite clear, minus a, okay, from a0 to a equal to minus t from t0 to t. From that we can get here that minus a minus a 0, that one is plus, of course, minus a 0 equal to minus k t. It is right, isn't it? So we can rewrite it into simple or simpler equation as let's say minus a, okay, minus here equal to k. So we get the first one, kt equal to, from here we get it already. Okay, now we go to the second one, k from the graph. Let's say rewrite this by from here go here, minus, oh sorry, that one equal, rearrange the equation becoming a0, okay, plus kt. Is that right? And now we just make this as y, this b, this ix. So when we plot this, meaning that one with this one, so what we get is k of a from there. Let's see like this, okay. So what we get from over there, y and x minus super a, 1 per a, and here is t. So what we find is the line, straight line like this, and that one is actually the slope equal to k, and the value here is 1 per a 0. So second already we get it, that one already done. We now just to get the third one, that t a half. Let's go to the clean one. So from the second order,